Look at this, a sequence of values over time. Some days add, some days subtract. Our goal is simple today. Find the best consecutive stretch, not scattered peaks, one continuous run. This is the maximum Subarray problem, and in this video, we'll solve it in two ways. First, the straightforward approach, then the efficient one. The efficient one is Kadane's algorithm. Let's start with the brute force idea. We are going to look at every possible consecutive stretch. First, we choose where the stretch begins. That's this red marker, the start. Then, we extend the end, one day at a time. That's the yellow marker. It slides forward. As the yellow marker moves, the blue bar grows. The blue bar is the current range we are testing from the red start to the yellow end. And we keep a running total for that blue bar. Instead of re-adding everything, we just take yesterday's blue total and add the new bar at the end. Each time we extend, we ask one question. Is this blue stretch the best we've seen so far? If it is, we update the green bar. The green bar is the best stretch we've found anywhere up to now. Then, the yellow marker reaches the end. We move the red marker forward by one and do it again. So it's two loops. Red chooses a start, yellow sweeps the end. Blue is the current candidate, green is the best so far. And yes, if you like names, red is I, yellow is J. But you don't need the letters. It's just start, end, current, best. We can make this faster, not by skipping the answer, but by changing what we remember. Here's the shift. Kadane's algorithm keeps only two things as it moves forward. In my animation, there are these two glass bars. One bar is the best total that must end today. The other bar is the best total we've seen anywhere so far. That's it, two values, and the entire algorithm is the daily decision that updates them. Before we meet Catherine, one quick thing. The key to Kadane is the daily decision. Continue what you've built or start fresh today. Creating a little story around that decision helped me see it clearly. So I'm going to share that story with you, not as proof, as a space to let the decision land. Meet Miss Catherine. This is a fictional Regency era bath. Catherine keeps a private diary of how each day feels. Positive days add, negative days subtract. And she follows a strict rule. Each morning, she compares only two stories. Continue the current chapter or restart today. Quick note before we continue. These gentlemen are not the point. They are just named for segments in Catherine's story, like chapter titles, so we can keep track stretches without numbers. Segment, Addington, months. Mostly up. Then it slips. She carries until she can't. Segment, Dimmesdale, days. Mostly down. Continuing costs more. She restarts today. Segment, Constable, a season. Steady gains, no drama. She keeps the chapter. Segment, Spackhurst, a spike. Fast up, fast down. She resets when it turns. Segment, Balance, a while. Need zero, nothing accumulates. She stops carrying it. Segment, Fairchild, month, up again. It compounds. This becomes the best. And that's Kadane in story form. One decision per day, carry or restart. And two memories. In my animation, those are the two glass bars. One remembers the best chapter that must end today. The other remembers the best chapter we've seen anywhere so far. Back to the algorithm. At each value, we update current. Either we start at today, or we extend yesterday's current by adding today. So, current equals max of today and current plus today. Then, we update best. Best equals max of best and current. So we never lose the best stretch we've seen. That's the algorithm. One pass, two stored values. Time, O(n). Extra space, O1. When the sequence gets longer, the difference matters. Brute force scales with the number of ranges. Kadane scales with the number of values. So you can run it as data streams in. Here's Kadane on a longer sequence. Same rule, same 2 bars, just more data. I want to share a little more about this project. When I chose Catherine's story, my wife helped me shape the character. That made the whole thing feel more real to me. I like building explanations with physical visual objects, because it turns formulas into something you can watch. And honestly, I make the videos I would want to watch. If you enjoyed this style, feel free to subscribe. Next, I'll explore embeddings and cosine similarity, and after that, decision making with A star and Digistrat. If that sounds like your kind of thing, I would love to have you along. Before we wrap, one last note. Dr. Hannah Fry once spoke about using math to understand love, knowing full well that life is more complicated than any formula. In the same spirit, this isn't advice, it's a tool. And while life won't always follow a pattern, the math itself still works. Thanks for watching.